I guess I'm standing between everybody and lunch, so we'll go through this real quick. All right, so my name's Mark McLean. I'm the program technical lead for the OpenStack networking project, codenamed Neutron. Used to be called Quantum. So just real quick, kind of set the stage a little bit. Let's talk a little bit about challenges in the cloud. Whether you're building a public cloud or a private cloud, we really care about, we want to have high density multi-tenancy. VLANs work real well, except for they don't scale. After a certain point, you can only create so many VLANs before you have to start doing tricks. Get a couple thousand of them, and then get any more than that, you have a lot of headaches. We want on-demand provisioning. If you're using a traditional data center, we're used to filing the ticket, having somebody go out, configure switches. That takes time. We want to configure these things instantaneously. Monty talked a little bit earlier about how the OpenStack infrastructure project creates lots of clouds daily. They use these tools to provision on demand. So the traditional networking doesn't scale, and then we also need to have the ability to move workloads around, especially originally if you're taking an existing app, maybe it's tied to the physical location and IP addresses. When we put this in the cloud, we want to have the ability to move those around on demand. Tackling these challenges, we have a lot of different tools available for us. We can use network virtualization. We have the opportunity to use different tunneling protocols from VXLAN, GRE, STT, as well as we can use OpenFlow, L2 fabric solutions, and always include the question marks because the networking community is always coming up with new and innovative ways to solve these challenges. So when we take a look at those challenges, what is OpenStack networking? Just to kind of talk about the basic abstractions compared to, say, Nova Network, is if we look at the orange boxes up at the top, we have virtual servers. Each of those virtual servers has a virtual interface called a VIF. In Neutron terminology, it's called, we refer to those as ports, and what you can think about is when you connect that VIF in to a port, that port's actually into like if you were using physical equipment into the port on the switch, you're connecting the wire. That port is on an L2 virtual network. That is a shared broadcast domain for L2 connectivity. And then for L3, we refer to this as subnets. So that's where you can define like 192.168.00/24 for a subnet. So what you'll see is at the top, Nova's responsible for doing the VMs and the VIFs, and Neutron's responsible for the ports, the L2 network, and the subnets. So when we use the API, we can actually create a pretty rich topology. So first call we can create a set of networks. We can create a 2-tenant networks. We can also create a public network. We can spin up a few virtual machines. We can create a router. And then we can connect all the segments together, provide networking to the VMs. And also, if you take a look, you notice that we can also connect VMs into more than one network, which is important for if you're doing a multi-tier app. Additionally, you can do multi-project setups, so you can have the same IP address space used by multiple tenants, and they overlap. This is one of the bigger differences from Nova Network. If you notice that the orange tenant is using the 10.0.0 address range as well as the green tenant, and in both cases, neither tenant is impacted by the other's usage of it. So when we take a look at what OpenStack networking is, it's very similar to how the construct of rest of OpenStack. The compute API, the networking API, and the storage API are all abstractions over their underlying implementation. So if you're talking about compute, it's going to be KVMs, and if you're talking about storage, in this situation, I have Ceph, or when we talk about networking, ML2, which is the open source version of the plugin. And these abstractions just abstract out the northbound API, the underlying technology. This wouldn't be an OpenStack talk if I didn't give the required diagram of how OpenStack is broken down. Yes, it makes your brain hurt a little bit, but when we really zoom in into Neutron, we're zooming into just this portion. And if we really go a step further, kind of if we take a block diagram of what's going on, up at the top you'll see there's many ways to interact with the API, from Horizon to CLI to Heat, as well as there are third-party tools which are written in other languages to interact with the Neutron API. Calls go into the Neutron process, and then what happens is that call goes through authentication, authorization, which is integrated with Keystone, and then that call is translated into the appropriate calls in the back-end layer. That translation is handled by Neutron's plugin layer. In this particular example, I'm showing modular layer 2, which I'll explain a little bit in a minute. And then module layer 2 actually interfaces with and configures the Open vSwitches on each of the Nova compute nodes to provide and configure the networks. So that's kind of the big high level. And so one of the plugins we have is ML2, but we also have many other drivers and plugins. So if you look there, we have a pretty rich set of companies that provide the drivers and plugins. They're well-known companies, and one of the things is we're adding more all the time. Some of the common features you'll find is support for overlapping IPs. Whether public or private cloud, that's a huge win for everybody. You don't have to renumber, you don't have to redevelop software. Many of us who are running legacy apps may have IP addresses baked into configurations and even in code. As well as we have DHCP. One of the new features that we added in Havana is you can now include custom port options. So if you have images that require options, say for Pixie booting, or you're running bare metal, or even the OOO project uses this feature. And floating IPs. And basically what floating IPs allow you to do is take a v4 address from a public network segment and map it onto a private address within the tenant's namespace. Many of us don't have the luxury of having a /8 at our disposal. We have constrained public IP address space, so we can use floating IPs to help us give public connectivity where we need it, and then directly to the hypervisors, or if not, via the router, we can have NATed outbound. Additionally, security groups, they're very similar to what you'll find in Nova, except for a couple different changes. One, they support overlapping IPs, which Nova Network does not. Also, you can define different security groups for each of the different VIFs on a VM. So that way the rules are appropriately applied in Nova Network. They're applied across all networks. As well as you can apply ingress and egress rules so that you can actually filter traffic exiting the hypervisor into the network. In Nova Network, you can only filter traffic exiting from the network into the guest instance. We also offer v6 matching. And in some of the plugins, actually will offload the processing of the security group rules into whatever the underlying technology. Some will actually use, say, IP tables, firewalls. Others will actually configure OpenFlow rules to apply. Metadata is pretty similar to what you find in Nova Network, except for it supports overlapping IP addresses, and also we provide support for non-routed networks. So modular layer 2, which is one of the newer features that we released in Havana, it's a driver-based architecture that combines, at least at the open source level, combines the OVS plugin and the Linux Bridge plugin. Previously, you had to choose one or the other. Now you can use both. And what it allows you to do is create layer 2 segments using both technologies. One of the things we added as part of the L2 feature was we added VXLAN support, which a lot of people are excited about. And also, we supported L3 separation. Previously in Neutron and Grizzly, the L3 module was baked into the particular plugin that you were using. Now that we've separated out the segments into drivers, we're also separated out the L3 routing so that it's possible, and some folks have actually gone through and created new L3 agents based on the separation so that you can, say, if you wanted to run an OpenBSD instance as your router versus, say, using Linux namespaces. We have other mechanism drivers available, and so in the first pass we released, we have Arista, Cisco, Hyper-V, and TailF provided drivers for mechanism drivers. I expect we'll see some more during the Icehouse release. And so ML2 is one of the ways that if you have existing layer 2 equipment, it's an easy way to integrate with Neutron. The interfaces for writing the drivers are much simpler, and there's a much lower implementation burden versus, say, implementing a full monolithic plugin. One of the unique features of modular layer 2 is we've added what we call L2 prepopulation. So if we have hypervisors A, B, C, and D, and then let's spin up, and so we have them all connected with tunnels, and now let's spin up 2 guests. So the tenant spun up a guest, and one of the hypervisors, one of the guests is running on A, and the other is running on D. If we wanted to discover and send, if we wanted to send traffic between the 2 hypervisors, what has to happen is we have to flood to do we have to flood the entire network to do an ARP request. Obviously, if we scale this up in order of if we have order of magnitude or more, that's a lot of traffic you're generating when Neutron already knows which hypervisors that the guests are running on. So with L2 population, what we're able to do is we're able to precede and put that information into the flow tables on the host. And so you only have to send your broadcast packet directly to the host that need to receive it. So as we scale up and add more instances within the same tenant, we only have to send traffic to the appropriate hypervisor. In addition to L2, we did several work on our advanced services. Neutron has advanced services for load balancing, VPN as a service, and firewall as a service. So if we dig in a little bit more on load balancing as a service, one of the changes we made is it now runs multiple node. In Grizzly, it only ran on one node. Now you can spin up several network nodes, and the scheduler will actually distribute the load balancing across the different network nodes. One of the nice things about that is you no longer have a single point of failure for all load balancing in your deployment. Load balancing as a service is now driver-based, which one of the biggest wins for that is now we have an open source version, which is HA proxy, as well as we have proprietary available. The current one in the tree right now is Radware, and I expect we'll see a few others coming as well as Icehouse. For VPN as a service, similarly, it is multiple node. Similarly, it's multiple node as well, but it also as load balancing, it provides site-to-site VPN via IPsec. We started out with IPsec because that was the biggest request we heard from the community. I know a bunch of you are probably thinking, what about SSL VPN or MPLS? Yes, we are working on those things, but they're coming a little bit later. The reference implementation that we used in the open source is OpenSwan. Currently right now, open source is the only implementation we have. There's been some talk by some of the vendors who are implementing proprietary ones, but they have not been proposed for the tree. Firewall as a service is a little bit of a different case. We released it as an experimental API in Havana. So one of the things that it does provides stateless filtering at the edge. And that's actually at the routing edge going to the public network in between networks. The team's still working on kind of proving out the API. The reason we released it as an experimental API is we wanted to get community feedback. We also wanted to get implementer feedback from the different vendors and participants in our community, both deployers and vendors as well, about what the API should look like. That said, there are vendor drivers available today based on this experimental API, again, to allow deployers a chance to test it out. Like I said, preview available in Havana. In addition to the services, we worked with the Horizon team to improve the experience in Horizon between Grizzly. Refactored several of the interfaces. You'll still find the same core components that you would find before, such as networks, subnets, routers, VPN. We made it a lot easier to select which NIC you're going to choose when booting. Previously, you didn't get this option. As well as our team's work to improve the graphic visualization of what the network topology looks like. Oftentimes when many people try OpenStack or in some self-service models, if you're doing heavy automation, you're going to be using the API and the CLI or some of the automation tools. But initially when people begin using OpenStack, they'll encounter and they'll use the dashboard. So one of the things we wanted to make sure is that there was a good experience. Also, unless you're a trained network engineer, a lot of us have a hard time keeping a visualization of what the network looks like in our head. So the Horizon dashboard gives us an opportunity to kind of visualize it. If you'll notice, this is displaying both V4 and V6 and dual stack networks. Neutron today supports both of these. So one of the things everybody's asking, we just had our summit in Hong Kong, is what's coming new in Icehouse? Yes, the Icehouse Street has a space, but when we all type it for release naming, the space disappears. So one of the things, the biggest changes that the Neutron community has made is external plugin testing. This is going to be required for all third-party code contributed to the tree. And what this does for you as a deployer user OpenStack is it increases the testing coverage that we have. One of the previous problems we had is the review team was able to review the code for, did it look like Python? Did it look like it ran right? Was the logic basically right? But there was no way for us to test because, I don't have a Nexus box sitting at my house, nor do I want one spun up all day long. So third-party testing, each of the vendors will actually contribute as they contribute code. Their systems will have to run a same CI check using some of the hooks that Monty talked about a little bit earlier in the infrastructure talk. So that testing will be implemented around Icehouse 2, and then we'll actually publish a list alongside of Icehouse to show you what the compatibility is of each of the plugins within our tree as well as the drivers. Also, in addition, with some of the folks in the community led by Red Hat, is we're working on improving Nova parity. We still have a few gaps, and so we're trying to get rid of the remaining few gaps, because one of the questions constantly we have is, should I use Nova Network or should I use Neutron for a new deployment? If you're starting a new deployment, greenfield, start with Neutron. If you've got to exist with Nova Network, we're working on making that transition a little smoother. IPv6, while we support dual stack networks today, it's a very limited set of how v6 is supported. It's also very opinionated that you get DHCP v6, which not everybody wants. We have several large telcos in the US that are actually working on helping us move v6, as well as some of the Asian telcos are excited to help us as well. Also working on making the L3 agent more highly available. Currently, right now, while we can reduce the points of failure within the deployment, we don't have HA, nor do we do shared connection tracking between the two different, between like an active and a passive namespace. So we have members of our team working on making the L3 routing both highly available, as well as also improving the amount of north-south bandwidth you have because across your deployment. And the last thing is L3 service improvements. Like I said, the load balancing as a service team is working on integrating SSL termination into the load balancing service, as well as offering layer 7 services. The VPN subteam is currently working on providing OpenSSL support so that you can kind of support that road warrior case. If somebody's working remotely, they can connect their laptop real easily into a cloud deployment. There's also a team working on MPLS. The one trick with that is how we provide a good open source story for that, so that still may only remain a proprietary extension. And then lastly, the firewall team is going to continue the work that they did and harden up the API, formalize it, and continue to work a little bit on investigating how we can do service chain insertion, as well as adding filtering between the zones. So there's several ways to contribute. Code's one of the easiest ways. Our code's available at GitHub. We also have blueprints and bugs. And even if you're not code oriented and you're deploying, the Neutron team appreciates feedback in the form of you can contribute questions via the mailing list, on OpenStack mailing list, or if you have development questions on openstack.dev, or we're also available on IRC. And then the last thing is, real quick, I hope to see many of you at the next OpenStack Summit. It is going to be in Atlanta in the spring, my hometown, so a little excited. So hopefully see some of you over there. Any questions? Yes. Yeah, so the question is what about VRRP support? And that's actually what we're going to be putting into the L3 HA. We're adding VRRP plus connection tracking. Yep. VRP is it's a virtual router redundancy protocol. It's basically Cisco originally started it, but it allows you to have both an active and a passive router all spun up and connected, and then it will migrate automatically the gateway, the public interface of the gateway, and also the internal gateway interfaces between the two instances, and fail over when Keep Alive detects that one of the instances has died. So the question is can a tenant actually span across multiple AZs? So currently right now, the only way to span multiple tenants is either as an administrator, you can plug in two tenants. You can plug in a tenant's network into another tenant's router and provide routing. That does introduce a few security issues in of itself, which is why we haven't allowed tenants to do a self-service model. One of the alternatives we're suggesting right now is with the IPsec VPN allowed is you can share you can share the keys between the two tenants, and they can actually create an IPsec tunnel between their two instances. IPsec is available now in Havana. Mm-hmm. Basically, by configuring as you would any other VPN endpoint. That is, yes. Single tenant across multiple AZs. Right now, most of the underlying implementations don't span outside a single AZ. It's an implementation. Just, it's a matter of going through the iterations. Oh, so the question is networking, is the storage solution integrated with networking? And actually, those two things are independent of each other. And so, particular at my employer, we actually do run Ceph, but it actually runs on a separate network than the tenant data networks. And actually, the reason that occurs is because the Ceph storage, in terms of block storage, is actually connected at the hypervisor level and orchestrated between Sender and Nova do that. Yes. So the question is, can I elaborate on MPLS support? Currently, right now, I do know there's one vendor, or actually one telco, which has implemented MPLS internally for their clients. And they've been testing it. They started testing it approximately 4 months ago. The one trick I said is we've been having is typically within the Neutron community, we require that there be an open source implementation in order to land in the tree. And so while they have a proprietary implementation, they haven't been able to develop an open source, or at least a good open source story for using MPLS, which is why I think SSL will land before we merge MPLS. But possibly Icehouse, more likely J or the K release would be my guess. I know the OOO team is working on deploying large bare metal deployments. Me personally, I've not deployed 1,000 bare metal nodes. So